Hello and welcome to the Researcher Podcast, your regular look at the research that's making waves in the scientific community and the people behind it. My name is Joe Fenton and I will be your host today. So today I'm delighted to be joined by Dr. Rick Stu Smith from the University of Tasmania. Rick is the author of Ecosystem Restructuring Along the Great Barrier Reef Following Mass Coral Bleaching. Today we'll be finding out a bit more about both the paper and the person behind it. Rick, thank you for joining us.
Thanks, Joe.
Okay, so before we get into your paper, could you tell us a little bit more about yourself and your academic career so far?
Yeah, sure. I suppose always been interested in fish and aquatic ecosystems since I was quite young, and so in terms of my career, it's certainly progressed in a way that has allowed me to stay close to fish in particular. But I've been lucky enough to involve diving and observing fish and counting them and things underwater as part of my data collection and part of my career. So lucky enough to spend a lot of time in the water for it.
Okay, so for those that may not have read Ecosystem Restructuring Along the Great Barrier Reef Following Mass Coral Bleaching, could you give us a brief overview at all?
Yeah, sure. So I suppose the way I describe this may require some background from the Reef Life Survey, which may come down later. But so we've, myself and Graham Edgar started a citizen science program 10 years ago called Reef Life Survey, which is now an international program. And it's about extending our scientific team basically to the most committed and capable recreational divers. So we train them to do the same standardized, really detailed methods for recording the fish diversity and abundance and the mobile invertebrates, all on a transect line underwater, and taking photo quadrats to get coral cover and algal cover. So we've had this team of, I think in 10 years, we've had about 250 divers contributing, and we've done almost 12,000 underwater surveys around the world, from the Arctic Circle down to Antarctica and all ocean basins between. So we've got this amazing, rich data set of what lives on rocky and coral reefs around the world. And we happen to have a lot of information from the Great Barrier Reef, from a couple of survey cruises with Reef Life Survey divers through to about 2015, before the bleaching event. And so when the mass bleaching event happened in early 2016, we kept an eye on it and managed to get teams back out there to resurvey the exact same sites at the end of the year, almost a year after the bleaching event, so that things had subsided a little bit. Well, the temperatures had subsided, but the coral had a chance to either regain the zooxanthellae and recover or die. So we were looking at the outcome of the bleaching event for the immediate future, and we were able to use a huge, rich data set from before to compare to. So that's what the paper was about. Basically, we were not only able to just look at how much the coral cover had changed as a result of the mass bleaching event, but what the implications were for the fish communities that lived on them and the invertebrates. So one of the things that most people know about bleaching events is that it has a big impact on some of the fish that depend on the coral for food, the small colourful butterfly fish, for example. But it also is important for habitat. But I guess the broader implications of mass bleaching events haven't been described to this extent, because they tend to be focused on one or two particular areas that are impacted. So where this study was unique was that we had an opportunity to look along the entire length of the Great Barrier Reef and out in the Coral Sea, an area spanning something, I think it's 15 degrees of latitude almost. It's a huge area, and the impacts were different from top to bottom. So it was quite unique in terms of the geographic scope and the level of detail of the data that we had available to look at the impacts.
So when I was doing the research for this particular paper and for this particular episode, I saw these pictures of pre and post reefs that had been affected by coral bleaching. So for those that may not be too familiar of this process, could you explain it to us in layman's terms at all?
So basically mass bleaching is just it's a term used to describe any coral bleaching that's not just localized. So coral bleaching happens when the water temperatures rise too much. There's a number of triggers, but they've been hypothesized to include UV radiation as well as excess temperatures. But basically, they're triggered by warm ocean events, which have been happening more frequently around the world in the last couple of decades, and are predicted to increase in frequency. But basically, when a mass bleaching event is when you see coral bleaching happening in heaps of areas. Basically, this last one in 2016 and in 2017 affected areas from the Western Indian Ocean all the way through to Australia and the Central Pacific. And I think in the Caribbean as well, actually. So it affected such a broad area just because the global sea temperatures were elevated for long enough to impact corals. So when the corals lose their zooxanthellae, the little algae that photosynthesize to provide part of their food source, the algae disappear from the coral, they're ejected, and the coral goes white. So that's why it's called bleaching. So you've got white corals all around the world. That's a mass bleaching event.
So rising sea temperatures and the reasons that you have just given us as to why coral bleaching occurs. But I'm just wondering why specific areas are affected more than others. And in your paper, you talked about the northern coral sea reef.
Yeah, so at local scales, it can be incredible how variable bleaching affect coral reefs. So something that was really obvious to us, there was a lot of reports from the mass bleaching on the Great Barrier Reef of the whole northern Great Barrier Reef being dead, basically. There was a lot of concern over the whole area, but when we were diving along there after the bleaching event, we could be diving on one reef that was absolutely hammered. It had barely any living coral left, and it was devastating to see. And then we could dive on the next reef only 2 kilometres away, and it could be untouched. So even though the sea temperatures were elevated across that region, there may be some local, we can only hypothesize why. Some of the reasons could be that there's local cooler water or currents flushing one reef when the other reef is sitting in a pool of hot water. Or there's also the possibility, or that we know that some corals are affected more than others. So the coral composition on one reef may be made up of less susceptible corals than the other. Even amongst the same coral species, we observe big differences from reef to reef. So yeah, I guess it's likely related to local conditions. What the corals on that particular reef at that particular place are experiencing, and whether they're stressed enough to be bleached. I think that was one of the important findings of our study, was this variability that happens isn't necessarily captured well in other studies, because they tend to look at one reef or one small area that's affected by bleaching. And so the outcomes that they find are not necessarily always generalizable, because they don't know what's happened to the other reefs nearby. Whereas we had almost an experimental design where we had reefs next to each other that experienced similar broad conditions, but showed different levels of impact on the corals. So the fish may have experienced similar sea temperatures, but their coral habitat changed in different ways.
And so with these localizations and the habitats of corals and fish, does it make it that much harder to predict when these bleaching events may actually occur?
Predicting when bleaching may occur is it's beyond my level of expertise, but there's oceanographers and modelers who have been working tirelessly trying to better predict when bleaching may occur. At the moment, there are short-term forecasts available. So there's a few NOAA from the US have forecast for bleaching, and there's certainly possibilities to identify that bleaching may be more likely to occur in the very near future, in short time frames. But there's not really much that we can do to predict them in the long term at this point in time. But again, I'm not the expert on the oceanographic events that largely cause these, and the climate events that drive them. So yeah, as far as I know, it's still very difficult to forecast. All we know at the moment is that these events are increasing in frequency, and there have been a few papers out that suggest they're predicted to continue to increase in frequency.
Okay, so in your paper, you talk about these 186 reefs that were studied, and then you moved into less studied and more remote areas. So I'm just wondering, what are the differences in the two, both academically and logistically?
So in terms of the 186 reefs that formed part of this study, these were reefs across the Great Barrier Reef and the Coral Sea where we had before and after data. So these were the reefs these were the sites. There was 186 sites rather than reefs. These were the ones where we could compare what happened to the coral and what happened to the fish and invertebrates as a result. The ones that were more isolated, the Coral Sea, the data we had from before were amongst the only data available because they're so isolated and poorly studied. The data that we'd collected out there was very much baseline data and exploratory data, and those Coral Sea reefs actually have quite a different fauna on them from the Great Barrier Reef, largely because of their isolation. So their fish and invertebrate fauna are much more similar to the reefs of Tonga and Samoa 2,000 kilometres away than to the Great Barrier Reef only 200 kilometres away, just because the species that live there are basically the ones that can disperse long distances. So the responses there were a little different from the Great Barrier Reef. The biggest, I guess, one of the more interesting findings of the study was that there were consistencies in the responses, and it was responses to temperature that appeared to be the most interesting and consistent responses amongst the fish communities in particular. So even if the coral and fish communities had different composition, there were some similarities in the way they responded to the warming.
So in your paper, you mention that you will not be able to understand the full impact of the 2016 coral bleaching for another 10 years. I'm just wondering if you could speculate what you believe will occur during this time and what its impacts would be.
I think one thing I have learned from lots of time under the water is that there's always ecological surprises. So we can predict things, but there's always things that go in different directions. And I'd say it's inevitable that some of these reefs won't recover to their full glory. You know, they probably weren't at their full glory even before this bleaching event. So I think the outlook for some reefs is probably not that great, but there are a lot of corals that actually grow much more rapidly than people appreciate, and I wouldn't be surprised if some of these reefs rebound quite quickly. We have quite a few herbivorous fish on Australian reefs, and they're not targeted by fishes, not at all really. So the parrotfish that play an important role and were one of the important results of this study are still there, especially in the southern reefs. And I've got no doubt that the southern reefs will bounce back reasonably well. The northern ones, I think, even if they bounce back from this event, the concern is what happens through the longer term, even more than 10 years, if there's more bleaching events. But based on other studies, the prediction would be that the dead corals will erode with storms, and the habitat loss, the structure of the reef will be broken up and result in fewer fish. That's the general prediction, but I'd say that it's not likely to occur at every reef, and certainly we'll see some variability in the responses. At least we feel like even in the northern areas where we observed herbivore loss, where the parrotfishes in particular declined in the northern warmest parts, we still believe that they'll probably come back because the losses and the big changes that we saw are likely to have been a result of temperatures which were elevated for a number of years. We had a number of hot years in a row, and a few cool years should see the return of those sorts of fish. So we would have hoped that at least herbivory isn't lost, in the northern parts yet, and that should assist the recovery.
That was actually going to be my next question. So moving on to the impacts of the piece, how do you think this piece could impact either the academic or, to put in quotes, the real world?
Yeah, so I think in the academic world, it's interesting because it covers a situation where that wouldn't have been possible without citizen science, without the Reef Life Survey program, and the amount of data that we've been able to collect over such a big scale. These sorts of things that would have cost millions and millions to do with a professional scientific team, and it wouldn't have been done. There's a reason that the coral sea reefs haven't been surveyed so well because of the expense and isolation to date. So some of the learnings from this academically are incredibly interesting and wouldn't have been possible otherwise. In the real world, which is obviously more important, I think we're lucky that this was Australia, and where we, as I said, we tend not to harvest the parrotfish. The parrotfish in the Caribbean have been long known to be an important component of the ecosystem that's been gradually eroded. And in the Pacific, there's many places where parrotfish are the preferred target. If they are as important as people believe in recovering reef systems that have been degraded by bleaching events and storms, and if they are as important as we all believe, then we certainly need to protect them on these reefs. And one thing that people haven't really been thinking about is what's the effect of temperature on these fish. The reasons we looked at this is because we've also done a lot of research in temperate environments, because Reef Life Survey spans temperate and tropical worlds, and it's a very different situation in temperate environments where herbivorous fish are actually less common. So as the water cools, as you go further towards the poles, you get fewer and fewer herbivorous fish. And so as waters are warming, we're actually seeing herbivorous fish extending further south and having a different form of impact. We've been observing that quite clearly in temperate areas, but the tropical the coral reef research community hasn't been paying as much attention to what's happening at the warm end. And there's lots of reasons that herbivores are affected strongly by temperature more than other groups of fish. But I think the real world implications for this are that there's the warmest parts of the world's seas, the warmest coral reefs, say in Indonesia and parts of the central Indo-Pacific, are possibly going, I guess we could make some predictions that it's possible that herbivores will suffer ahead of other species in terms of effects of warming. So it's something we have to be prepared for, and I think that management actions need to consider. So stopping the exploitation of herbivores ahead of other groups of fishes is possibly an important step, but certainly something that needs to be looked into more. So if we want our coral reefs to recover from future bleaching events and cyclones in the warmest seas, we have to consider the effects of temperature on the species that help the reefs recover.
Okay, so as the world becomes... Actually, let me rephrase it. As some countries have become far more environmentally enlightened, I'm just wondering, has there been any funding by the Australian government to protect or reverse some of this ecological damage that has been done to the Great Barrier Reef?
I'm probably not in the best position to answer that, but I believe so. We did see a big commitment by the Australian government towards research on the Great Barrier Reef, and I have heard that there's been quite an increased focus on reef restoration and trying to, I guess, enhance resilience of corals to thermal stress. So there's a number of initiatives and funding avenues that seem to be taking off and being spurred on by increasing frequency of disturbances in general, not just mass bleaching events. So in Australia, I think it's probably true that there's an increased focus, but we always have valued the Great Barrier Reef so much in Australia, and the Australian government has always put a lot into it. And I guess it's very obvious to me coming from, I live in Tasmania and in the cool parts of Australia, and it's very obvious the difference in funding that the Great Barrier Reef gets compared to elsewhere, which is obviously fantastic for the Great Barrier Reef. So I think that the funding situation has possibly been improving, but as I said, I think I'm probably not best placed to answer that specifically for coral reefs, because much of the work that I do isn't funded by coral reef specific funding sources.
Yeah, I guess that makes complete sense. And so I'm going to move on to more of the personal side of this podcast and ask you, who has been your biggest influence throughout your academic career?
Obviously the first answer is my wife, who's been incredibly supportive through my career so far, and stood by and supported me when I've been spending lots of time in the field and away and training Reef Life Survey divers and so on. But in terms of academically, Professor Graham Edgar at the University of Tasmania has been a mentor of mine. He took me under his wing probably 12 years ago and has been an incredible mentor and certainly influenced my work heavily. And I certainly owe him any of my successes in terms of, Reef Life Survey was his idea and together we built it, but he's certainly a genius. The other person that's influenced my work a lot is Amanda Bates. at the Memorial University of Newfoundland in Canada. She worked in Tasmania for a while, and her interests in how temperature affects the physiology of animals, of marine animals in particular, was certainly a really great crossover. She was coming from the physiological side of things, and I was coming from the sort of field ecology and community ecology side. And we both sort of met in the middle with how important temperature is for all of these influences. So, yeah, Graham Edgar and Amanda Bates in terms of academically.
Okay, so this next question is a question I'm very much looking forward to asking you. And that is, how do you spend your week? Because obviously there's reading and researching, and then you also have your diving as well.
Many academics about this that they'll say it's a 150% full-time job. I think for me, Reef Life Survey is an extracurricular activity. So my day job is at the moment, and for the last few years, has been doing research that's needed and relevant to the Australian Government Department of Environment. And so I get to use the Reef Life Survey data a lot and other reef data and reef biodiversity data. But that is my day job, while on the weekends and in the holidays, I'm training Reef Life Survey divers and participating in the monitoring by Reef Life Survey. We also do some of that, of course, as a day job at work with the scientific team at the University of Tasmania. But some of the adventures with Reef Life Survey are certainly enjoyable and make it worthwhile putting in the extra time that well and above the regular work hours. So a lot of my week is certainly spent. A lot of it's working, and lots of field trips, and that's certainly the bits I enjoy. The field work is fantastic.
It certainly sounds even more than 150%, to be honest. Okay, so my next question is a question that many of our listeners may be using in their academic lives now, and that is all about productivity. So do you have any tips that you've used to increase your own academic productivity at all?
I think the easiest thing for being productive is doing something that you love. So it's quite easy if you chase your dreams and you're doing the work that you love, you'll naturally be more productive. And so for me, it's not that difficult. I think also being prepared to put in the extra hours. I think people realize too, in an academic career, especially if you're doing your own research and you have some research flexibility, that to maintain that, you need to be able to put in the extra work to do the less exciting things like reports and grant proposals, and you need to work hard on those things to be able to do the things you love. So basically, you're driven to be productive, to be able to do the things you love, and you have to spend the time doing those things. So, I think in terms of, there's no tricks to it. The only tip is just chase your dream and you'll naturally be productive. If you're doing something you don't enjoy, it's going to be an uphill battle.
Okay, and it's now time for my last question. And I've got a very strong feeling that it's going to link back to the previous question I asked you. And that question is, what would be your one piece of advice for anybody that is just about to start their PhD?
Certainly chasing your dream. I think there's a lot of negativity out there at how difficult it is to find and maintain work in science, especially marine science. I've had friends and relatives who wanted to be marine scientists who didn't chase it because they felt there wasn't enough work opportunities. And I have to say, it's not easy. It's not like there's lots of work opportunities. But if you love it enough, you work hard enough, and you do well enough, you'll find work. And the other thing that most people realize is that being prepared to move around to stay employed is important. But for a PhD itself, I'd certainly recommend you need to stay motivated through the course of it. So doing something that you love is critical for the PhD. Something that can provide you with good track record. You don't expect to change the world with your PhD. You do something that gives you good opportunities to publish good papers and is something that you'll stay motivated with. And then, chase your dream for your career, and certainly network and get to know people, get to know all of the renowned researchers, and find a good mentor.
Amazing. Thank you so much. So that's just all about time we've got for today on the Researcher podcast. I've been delighted to be joined by Rick Stu from the University of Tasmania. Rick, thank you so much for joining us.
No worries. Thanks for having me, Joe.
And thank you for listening, everyone. Until next time. You've been listening to the Researcher Podcast. You can follow us on Twitter, Instagram, Facebook, or LinkedIn. You can also follow us online at www.researcher-app.com. Or, alternatively, you can drop me an email at joseph.fenton@researcherapp.com. Researcher is free to use on iOS, Android, or on your web browser. And if you enjoyed this podcast, don't forget to leave us a review.